When we talk about the MERN stack, we of course have to understand the E and the N part, Express.js and Node.js. Of course, we'll build the entire backend of this application with these two technologies working together, and therefore there you will learn a lot about them. But in case you're really new to Node.js and Express, I recommend that you check out dedicated resources like my Node.js The Complete Guide, but B, here in this module, you'll also get a brief refresher. We'll quickly dive into Node.js and Express, understand what it is all about, how it basically works, and therefore hopefully by the end of this module, we're all roughly on the same page. Now again, this module is not there to replace a complete Node or Express course. There is a reason why that course has more than 30 hours on its own. But it's there to make sure that if it's been some time since you worked with Node or Express, or you haven't worked with it but you're learning it simultaneously to this course, we all can get started with it quickly, and it's not all brand new what you're going to learn in the next course modules thereafter. So in this module specifically, we'll have a look at what exactly Node.js is again and how it roughly works. And of course, we'll also explore the E, Express.js. What is Express about and how does it work, and why do we use it? Why do we need it when we build a backend with Node? So let's dive in. What is Node.js? Wouldn't hurt to understand that if we want to write some Node code, right? So Node.js is in the end a host environment for JavaScript, a runtime for JavaScript, you could say. Now, for that, of course, it's important to understand that JavaScript is the programming language. And most of us started with JavaScript in the browser. It is the only programming language we can use in the browser to write some logic there, to execute some logic there, to change the document after it has been loaded and so on. For all of that, we need JavaScript. The browser, therefore, is one host environment of that JavaScript language, but it's not the only one. Basically, one of the most popular and important browser JavaScript engines, V8, which is the engine built into Chrome, has been taken out of Chrome. It's still in there too, but it has all been cloned and is now maintained as a standalone project. And that is basically Node.js. It's a JavaScript engine originally built for the browser, now working without a browser, and enriched with some extra APIs. So it allows us to run JavaScript outside of the browser, and of course that means that some APIs were dropped. For example, we no longer can interact with the DOM if we're writing Node.js code, because we don't execute the JavaScript code in a browser environment, and therefore there is no DOM. But new APIs are available. In the browser, for example, you can't really work with the file system. For security reasons, you can't store files on the system of your users or read files from there. Well, in Node.js, you can do that because Node.js does not execute on computers of the visitors of your web page, but instead you execute it on a computer of your choice. For example, on a computer, on a machine you expose as a server to the internet. That is Node.js. It's JavaScript outside of the browser with new tricks learned and some tricks unlearned, I guess. And with Node.js, we can write any kind of application, any kind of script with JavaScript. Doesn't have to be code that handles incoming requests, but often it is, because one popular use case of Node.js is to use it to build web servers which handle incoming requests, maybe talk to databases, and also send back responses, so that we can use Node.js basically as a replacement for PHP, for example, or Java, or ASP.NET. That is one very prominent use case, and it is the use case we will look into in this module, because it is exactly what we will use it for throughout the rest of this course. Now, to play around with Node.js a little bit, I prepared a brand new project here. It's basically an empty folder which I opened with my IDE, Visual Studio Code. And in there, we're going to write some Node.js code, execute it, and understand how it works. Now, Important for that, of course, in case you haven't done so yet, you need to install Node.js. Simply download and install the latest version from nodejs.org. It should automatically pick the right operating system for you. If not, click on Other Downloads to choose one manually. Simply download the latest version there, walk through the installer this gives you, and you can leave all the defaults there, and hence, by the end of the installer, once you went through the entire process, you will have Node.js and another tool, NPM, which stands for Node Package Manager, installed on your system. Now let's ignore that NPM tool for now, and let's write some Node.js code. For that here, I'll add a new file, app.js. You can name it however you want. And in there, we can write normal JavaScript code. We can, for example, create a constant, username, and then console log that if we want to. Now, important, this here uses next-gen JavaScript syntax. I'm using const and let instead of var. And in general, throughout this course, I will use modern JavaScript syntax, arrow functions, destructuring, spread operator, and much more. So in case you're not really familiar with this modern JavaScript syntax, you should definitely look into some dedicated resources which teach you this modern syntax. For example, my accelerated ES6 JavaScript course, or of course my JavaScript to Complete Guide course, which teaches you everything about JavaScript, including a little introduction to Node.js actually. So we have this basic script here. And if we now save this file, we can execute this with Node.js. For that, let's open the terminal here in this IDE. It's the normal terminal, just integrated into the IDE. And it's already navigated into this folder, which is the convenient thing about it. And there you can run node app.js. The node command is available because you installed Node.js on your system. And then we just type the file name, including the extension, of the file of the JavaScript file we want to execute through Node.js. If you hit enter, I see Max here, and you should see whichever name you entered here as a username, because that is what we do in this script. Now it is noteworthy that if we try to enter alert here and we execute this, we would actually get an error here. We get an error that alert is not defined. This is the thing I mentioned regarding some APIs not being available. The alert function, which does exist in a browser environment, does not exist in Node.js. And this kind of makes sense because the alert function opens an alert in the browser. Here we have no browser. Node.js has no built-in functionality to open some window on your system. That's not how it works. So that's one of the APIs which we can't use anymore. But no worries. There will be new APIs. For example, we can write to a file. For this, we need to import this file system functionality. If you only worked with browser-side JavaScript and you haven't worked with modern project setups there, which use bundling to combine multiple files, you might not really know the concept of imports and exports in JavaScript. You might simply work with multiple script imports in your HTML files to import multiple scripts. Well, in Node.js, and also, by the way, later in React.js, where we will have a build workflow which supports bundling and splitting our code across multiple files, we are able to import functionalities from file B into file A, and we're able to export functionalities so that we can use them in other files. And it is important to understand that with the exception of some very few global functions, everything which you want to use in a file has to be imported before you can use it. So for example here, I want to write something to a file. For that, conveniently, Node.js has a couple of built-in core APIs, just as the browser has a couple of built-in core APIs like the DOM API. For working with the file system, Node.js has the file system API. We import it with the require function. And that's important. The require function is a function globally available in Node.js, one of the very few globally available functions. Now, require takes a string, and that either is a relative path to one of your files where you're exporting something, or, in case of the file system or other core baked-in modules, the name of that module, in this case FS for file system. This is a module which is available with the default installation of Node.js. You don't need to install it separately or anything like that. Now, require is a function which tells Node.js that you want to import something from that file, or in this case, this module you're pointing at. Now that something, that object of functionalities, then is returned by the required function. So we should store it, in this case in a constant, which I'll also name fs, though this name here is up to you. You could name this however you want. Now we can use this file system object to use a couple of methods which are built into this file system module Node.js offers to us. Specifically, there is a write file method. The write file method takes a path to the file we want to write, and then the data we want to write to that file. Now the path in its simplest form can just be the file name, and it will always be written into a location relative to the script you're executing. So here, for example, we could have userdata.txt to create a text file, and it would create that userdata.txt file next to the app.js file. Second argument is our data, and there I will enter name plus username. So I'll just write a string as data to that file. Now with that, there is a third argument we have to provide to write file, and that's a callback, a function which will be called for you once this operation is done. Because write file, like many functionalities built into Node.js, is an asynchronous task, which means it can take a bit longer, especially if you're writing or reading a lot of data. And therefore, Node.js does not block the execution of the other JavaScript code. Instead, it will outsource this longer taking task to the Node.js environment, which is able to use multi-threading and so on, which JavaScript, the language itself, is not. And it will call a function once it's done. This function will get an error object, which is null if no error occurred, or which is not null if an error did occur. So if error is truthy, we know we have an error. So in this case, I just want to log the error. And otherwise, I'll just log wrote file. I'll return in here so that we don't log this in case we do have an error. Now with that, we have some valid JavaScript code which will run in the Node environment. And if we now call node app.js again, you see wrote file here, and you see the userdata.txt file appear here. And if we look into that file, we see name colon, and then, well, the value we stored in username. So this is also Node.js code using one of the APIs, which is only available in the Node.js environment and not in the browser environment. Other than that, other these special APIs, it's regular JavaScript code, and therefore everything you know about JavaScript also applies to Node.js code, because it is JavaScript. The only exception really is which APIs you're able to use. All the browser-specific APIs like the DOM and so on are not available here. Instead, you have new APIs. So Node.js is JavaScript, or allows us to run JavaScript anywhere. Now, of course, we can use it to write our own utility scripts, like, for example, a script which stores a name in a text file. Well, arguably, that's not too useful, but you could imagine writing a script that does way more useful things. Of course, you also have methods to read files, to search directories, and you could write a script which automatically cleans up your computer, which creates an audit file with all the files you added since the last time you ran the script, or whatever you want to do. Your imagination is the limit. But it's not what we're going to do here. We want to instead use Node.js to write a web application, specifically a web server, which we can use to send requests to and get back a response. To create such a server, we'll import another core module which is part of Node.js, and that's the HTTP module. The HTTP module allows us to create a server. It has a create server method which we can call, which is of course very convenient if you want to create a web server. The important thing here, by the way, is if you're coming from something like PHP, if you're used to working with that with Node.js, you don't just write the server-side logic, so what you would have written in PHP as well, but that with Node.js, you also create the server. In PHP, that's different. There, you use something like Apache to run your PHP code. You don't do that in Node.js. Instead, there, you use the language or the runtime itself to create the server. So create server is the method here, and it takes one argument, the request listener. So basically a function which is triggered whenever we have an incoming request. This gets two arguments, a request and a response object. The values for these arguments are passed in by Node.js when such a request reaches the server. create server, then returns a server object. And on that server object, you can call listen, a method which will set up an event listener for such incoming requests. To listen, you can pass a port number. In this case, I will go with 3000, or actually let's go with 5000 because that's the number we'll use later as well. Now, this opens up a local server on your machine, not exposed to the internet, of course, unless your machine you're developing on is open to the internet, which it should not be, by the way. And then you can send requests to the server under localhost :5000, which is the port number here. Now, for every request you send, you will reach this function, and in there, we don't do anything. Now, before we populate this with some life, it's important to understand that the listen method here will spin up a server, which of course is an ongoing process, which means it won't shut down. You won't be able to enter new commands unless you manually shut down that running process, because it's an ongoing listener which continuously waits for incoming requests. It's also able to handle multiple requests simultaneously, which of course is a must-have for a real server. So with that, let's maybe print console log incoming request here in this function, which should be triggered for every request. And let's console log request.method. The request object is a huge object with a lot of properties and methods. And request.method is a property which gives us the HTTP method which was used for the incoming request. We can also, for example, print the URL which was used. Now, and what we should also do for every incoming request is send back a response. Otherwise, the browser which is sending the request will eventually throw an error when the request times out. And it will time out if you're not sending back a response. Now, for sending back a response, you can use that res object. And there you have an end method, which basically means I'm done configuring the response, please send it back. This method also takes some data you can send back. So here, for example, we could set back some simple text, success. If we do so, and we save this, we can now execute this file again, and now you see what I meant. It doesn't quit. I'm not able to enter a new command. You can always quit manually by pressing Ctrl and C, but then the server is not running anymore. So of course, as long as you're developing, you don't want to do that unless you changed some code and you want to restart it with the new code. So here I will start it and keep it running. And now let's go to the browser, and there simply enter localhost 5000 and visit this page. And what you should see there is this success text. And that's of course coming back from our response function here, or from our request handler and the response we're sending back. Now, sending back just some plain text is boring. Why don't we send back some HTML code? Of course, this is not a totally valid HTML document because I'm missing HTML and so on, but the browser will still be able to render it. So here I'm sending back a h1 tag. Now, if I reload, we see no change. And that, by the way, is a common source of error. If you change your code here, you need to restart your server, because when you run your file, if you run Node app.js, it executes that file. And if you thereafter change the code in there, it doesn't automatically re-execute it. So we manually have to stop the server and rerun it with Node app.js if we changed the code. Of course, that's a bit cumbersome, and later we'll see a more elegant method of handling this. For now, let's just restart it. If I now reload here, we see this looks like a h1 tag, and indeed if we inspect it in the browser DevTools, we see this is a h1 tag here. So this was sent back and interpreted as HTML by the browser. Now, if we don't want the browser to interpret this as HTML, we can call the setHeader method on the response before we end and therefore send it, and set the content type of our response body, so of this data we're sending, to, let's say, text plain. This tells the browser that what we're sending back should not be interpreted as something special, but as plain text. So if we save that and we restart and reload, we see the HTML tags here because this is output as some text. My browser wraps this into some pre-tags here. That's just something the browser does by default. The magic really is the thing in between. It's just interpreted as text. You can also see this, by the way, if you go to the network tab in the browser and you inspect the request which was sent there. Here you see the URL and the method. And if you scroll down, you see on the response header, the content type was set to text plain, which causes this way of rendering it. Of course, we can also set this to text HTML to basically get the same behavior as before, where if we now reload this, it is indeed rendered as HTML, because that is also what we're telling the browser from our server. Now, this is how we can send back responses, and if you're already wondering if this is the best possible way, because writing HTML code like this certainly is not too nice if we're writing longer code, then I can definitely comfort you. This is not the final way of how we will write our code. After all, this is just Node.js. We haven't seen Express yet. Before we see it though, let me give you one other reason why we might want to use it. And for that, let's actually write some code which sends a post request to the server where we then want to extract data and then send back that data to the client, let's say. For that, to be able to send a post request, I'll create a form element here. And in there, have an input type text with the name of username, just like that. And a button, create user. Make sure you got your opening and closing tags right. And that button will be of type submit. Now, this is definitely not so readable. I am aware of that. It is all the HTML code we need to write here though, so I'm doing it all in one line. As I mentioned, this is not the final way of how we will do this later. Now, if I save this and I restart my server and I visit this page again, I see this input field in this button. Styling is awful, but it's also not what we're talking about here, so this is fine. Now, if I enter something here and I click create user, the browser by default sends a request to the backend. It sends a GET request and appends the entered data as query parameters. Now, I don't want that default, so I'll set the method to post, which means the browser will now send a post request. It will send it to just our domain. Now here in our request handler, we can now check if request method is equal to post, which means the form was submitted. And then we want to extract that username here and do something with it. Maybe send back a response where we render that username in an h1 tag. Now, how do we get that data out of our request though? Well, first of all, let's create an else case. If we're not getting a post request, then I want to return this content here. So now in the if branch, I want to get the data which was part of the request, because for a post request, the browser will automatically add that username here and the value the user entered to the request body. So I want to extract this here. Unfortunately, there is no request body property or anything like that, which would give us convenient access to it. Instead, we have to register an event listener for the data event, which means we're getting new data, because data is actually streamed into the server in chunks. So we're actually getting it in chunks instead of one big chunk. Now, for such a small piece of data as we're having it here, it probably is in one chunk, but that's not guaranteed. So here, I then get my chunked data in this callback function, which we have to provide to this event listener. And I will construct my body here, a simple string, to which I'll now add this chunk. So I'm building up a string. This chunk here will actually be something which we can use as a string. Now, at some point, we'll also be done parsing data. So we'll add another event listener actually in front of the data event listener so that this is set up first. It's not triggered immediately, it's just registered immediately. And there we'll have a callback function which is executed once the entire request body has been parsed, once the entire request has arrived. So once we have in the end built up our body. Now here I then have my body. So for now, let's just console log body and look into it. And also send back a response where I for now have just a h1 tag, which is empty, or which is not empty, but which doesn't have our body. But I say, got the post request. And now with that, let's restart the server, reload this page, localhost 5000, and send another request. Now I go to this page here, which is great. And on the server side, we see this output, username equals menu. So that's what's in my body after everything has been parsed. So here we can get the username by taking our body, splitting it on the equal sign. Split is a default JavaScript method available on strings. This will give us an array with two elements. First element is the part in front of the equal sign. So username in this case. Second element is the part after the equal sign, menu. That's the part I'm interested in. So I access the second element with index 1 on the created array, stored it in the username, and now here we can output the username. For that, we could use template literals or just concatenate a string like this and output the username between the h1 tags here. With that, if we restart the server again, so quit it and restart, and we enter localhost 5000 again, don't reload, just visit localhost 5000 again. We try this one more time, now we see menu here. Now, this is a lot of work for sending responses and even more than that, for handling incoming data. And that's also the reason why we typically don't want to work with Node.js only. We could do that, but just with vanilla JavaScript only in the browser, that means we have to reinvent the wheel a lot. We have to find a lot of creative solutions for problems like this when we need the data, and therefore it's not what I want to do here. Instead, let's have a look at Express.js and see how that can help us. So we saw Node.js and that it can be a bit cumbersome to work with Node.js only. What is Express.js then? Express.js is a framework for Node.js. So that means we use Node.js, we write JavaScript code in the Node environment, but Express makes certain things easier, just as React, which by definition is a library and not a framework, but it's pretty close to each other, just like React makes things easier in the browser, or Angular, or Vue, or other libraries or frameworks in the browser. The idea behind a framework always is to give you a lot of utility functions and methods and things that allow you to focus on your core business logic and not so much on reinventing the wheel and building all these core primitives or doing all these primitive tasks like parsing data again. So it makes building web apps, server-side code in the case of Node.js, much easier. And one thing that is specific about Express, or specific to Express, is that it's middleware focused, which won't tell you much right now, but by the end of this module it will. So let's add Express.js to our simple application here and see how that simplifies things. Express is a library for Node.js, and thus far we have a Node project where we're only able to use Node core modules. To add third-party library, we need to convert this to a, you could say, managed project. For this, let me quit the server here. And now let's use npm, a tool which was also installed together with Node.js. npm stands for Node Package Manager, and indeed it is a tool for managing packages for Node applications. So for adding third-party libraries, you could say. Actually, you will later see in the course that we don't just use it in Node apps, we can also use it in front-end apps, in the React app, but for the moment, let's focus on Node. Now, to use npm, to install packages here, we first of all need to convert this here to a managed project, and we do so by running npm init. Now, we're asked a couple of questions with that, and you can simply hit enter everywhere to just confirm this. And once you're done with all these questions, you get a package.json file. This holds some general configuration, which is all fine, but more importantly, this will store all dependencies we will install. And to install a dependency, in this project folder, we run npm install, then the name of the dependency, in our case, Express is the name, just Express, like this, and then also here -- save. This will tell npm which kind of dependency this is. -- save for a core app dependency, which we use in our application code, or -- save -dev if it's a development only dependency. So some tool which helps us during development, but which we don't need thereafter. So here it's -- save because Express will make up a core part of our application. And here I actually get an error that I can't install a package under a package which is already named Express. And indeed, here the name was Express. Let's rename this to Node Express in the package.json file and repeat this npm install command. And now it will go ahead and add this Express dependency to this project. To be precise, it will do two things. It added this dependencies entry here in package.json, and it added a Node modules folder. In that folder, you'll find the Express package under E, but you'll also find a lot of other packages. These are dependencies of Express and dependencies of dependencies. Now, this folder can get quite big, so whenever you share your project with someone else, it's quite common to actually delete the Node modules folder so that only your code files are there. And now to recreate it, because you have these entries in package.json, you can just run npm install, and this will go ahead and install all the dependencies with the versions that are mentioned here into your folder. It will recreate the Node modules folder, therefore. Here it is. So now we get Express installed. How can we utilize Express? Well, we can utilize Express to simplify this listening to incoming requests and doing different things for different types of requests. Because besides parsing the data, which is cumbersome, it's also cumbersome that we have to check the method like this. If we have more and more methods and even more different URLs which we want to check, we have to add more and more if statements to this single request listener which we have. Not ideal. So let's actually get rid of all of that so that we have an empty app.js file again, and let's use Express for that. Here, I require Express just as before. I just specified a name here. This is not a core module, but the installed module. I require it by the name of the module, in this case Express. And now this thing which we get here in the Express constant turns out to be a function. You'll learn things like that in the official docs of packages, in this case in the official docs of Express. This function will give us an app object. So we'll call Express as a function and store the result, which is a rich object full of functionalities and features, in this app constant. One feature which we have here is again a listen method. So here I will again specify the port 5000. What we don't have to do here is call create server. Express will do that under the hood and basically expose that server object enriched with a lot of other functionalities on this app which I'm storing here. So now with that, we could execute the file again and have a running server, but of course one which doesn't do much. Now to handle our get route, when I just enter localhost 5000 like this, which currently is not supported because I have no routes or no supported requests at all here, to handle that, we have to register a so-called middleware here in Express.js. Because Express has one core philosophy, which is basically that every incoming request is funneled through a bunch of middleware functions, normal functions in the end, which are able to get data out of the request or manipulate the request even, and also manipulate the response and eventually send it back. That's the idea behind Express. You have a bunch of functions which can be called on incoming requests, and every function can do something with this incoming request or with this response which is about to be sent. You can only send one response per request though. Now, middleware is registered by calling the use method on app. Use is a method provided by the Express library on this app object. In its simplest form, this takes a function. A function, here I'm using an arrow function, which takes three parameters. A request object, which is the incoming request, basically an object similar to what we got with vanilla Node.js, but it is an object enriched with some extra data. A response object, also similar to what we had in the plain vanilla Node app, but again enriched with extra functionalities. And the third parameter is a new one. This is a next function, which you call if you don't want to send a response to this middleware, but instead you want to forward the request to the next middleware in line. If you're not calling next, then any middleware after this middleware, if we had more than one, will not be reached by this request. So you should always call next, unless you are in a middleware where you want to send back a response. Since you may only send one response anyways, there is no need to execute any other middlewares thereafter. So here we could create a middleware which sends back a response, and here we have a send method actually, where we can have our body where I now again want to render that form. So on that form, we had a method of post. And then in there, we had an input of type text with a name of username. And we had a button, opening and closing tags, where we had create user. And that button was of type submit. That's the setup we had before. Now we have it again. With that, if we now save this and we execute this file again, and I go to localhost 5000 again, we see that form, which is great. Now that form is of course nice to have, but it would also be nice if we now could do something useful with the post request. For that, let's add another middleware. A middleware which is also reached, and I will copy that middleware function. And for the moment, I will just console log middleware here, and then call next, so that this middleware does not send back a response, but does something, in this case just log something, and then forwards the request to the next middleware in line. Let's restart the server by quitting it and restarting. And if we now send this request again, you will see middleware here. By the way, you could also see this twice here if the browser is by default also requesting a fav icon, which my browser is not here at this point. Then this fav icon request would also go through the middleware. You can just ignore it. Otherwise, you will just see one middleware log here. So now we have that extra middleware, but this doesn't do anything. Well, what could we do in here? We could parse our request body. For that, we could bring back what we had before. Our onListener, where we get our chunks of data. Then here we have the body, which is an empty string initially. Then we basically append our chunks of data there. And we also have the end listener here, which executes when we are done parsing the incoming request body. And in there, I can get my username by calling body split on the equal sign and extracting the second element. And now I want to add a request body field, and I'll do this just with the dot notation on the request object. I'll dynamically add a body property and set this to an object where I set the name key to my extracted username. And thereafter, I call next. Please note that I call next inside of the end handler so that we only commence to the next middleware if we're done parsing the incoming request data and not earlier. So now we go on to the next middleware in line, and in that next middleware, the request body should be available. So in that second middleware, let's check if request body is a thing, if that is set. And if it is set, I will return response send, return so that the code thereafter doesn't execute, because I either want to send this response or send that. Alternatively, we could wrap this into an else block, but we don't need to do that if we simply return here. And here, I want to have my h1 tag, then output request body .name. .name is the property where I'm storing the username. And then close the h1 tag. If we do this, let's restart the server, go to this page again, hit enter, and I get undefined. So that does not work. Why does it not work? Because I'm always setting request body. Even if we're handling a normal GET request, which has no attached data, this end event listener will fire. So request body will always be set, in this case just to an object where name holds undefined as a value. So I will tweak this and check if username is a thing, if this is truthy, and only set request body if it is a thing. Now let's restart again. Hit enter again, and we see the form. Let's enter menu, create a user, and we see that here. So now we're doing the same as before, but with Express. Some things maybe got a bit easier, but overall we didn't gain much, mostly because we still manually have to parse the data here, right? And we still need an if check to see which kind of response we want to send. So these are two things we want to improve. And actually there is a third thing. Always having to restart that server, that's annoying. Let's get rid of that too. So let's finally get to the point where we can see the real advantage of Express. Before we do that, let's make sure we don't always have to manually quit the server and restart it. For that, I'll quick it one last time, and now let's install a new library with npm install, and that is NodeMon. Install it with --save-dev, because this will be a development-only library. We'll not use it in our code, but to simplify our development flow, our development process. Because NodeMon is a tool powered by Node.js, which actually will execute JavaScript files with Node.js, but it will not just execute them, but also watch them, watch all files in the project folder, and whenever any file changes, it will restart the server automatically. So whenever we save a file with changes in it, it will restart the server. For that, we need to use NodeMon to run our app.js file, and for that, in turn, we can go to package.json and use a so-called script. Scripts are simply, well, short utility scripts we can execute, and here we can add a start script, and the name should be start, and then, for example, execute node app.js. With that, if I run npm start, I execute this script. By the way, start is a special name. If the script would be named differently, for example, dev, you would have to run npm run dev. Only for start and test, you can omit the run keyword and directly run test, or in our case, start. Now, if we do that, then this code here will execute. So in this case, node app.js, which is the same as before. Now, that's not what I want here. Instead here, let's quit that server and use NodeMon. NodeMon is this package we just installed, and this is available as an executable inside of this project. It's not available globally on your machine. Executing NodeMon there most likely will fail unless you installed it globally before. But inside of these scripts, any dependency here, which is an executable script or executable tool, will be available. So now if we save this package.json file with that change made, if we execute npm start again, this will use NodeMon. We see a more colorful output there. And in the end, this executes app.js, which is great. But now you will see that if I change something, for example, here on this response, I add user : as an extra text, and I hit save, you see this restarts, and hence here, we see that change in action without us manually quitting and restarting the server, which of course is great. So that's a little convenience added. Leave that process running. You can always quit it with Ctrl+C once you're done for the day. And with that, let's actually focus on our logic here. Because now I want to make sure that I actually am able to parse the incoming request in a more comfortable way, that we don't have to manually parse it. For this, I'll install a new package, and here I will quit the server just to install that new package, which will not do all the time. And this package is named body-parser. Install it with --save, because this will now be a package which we use actively in our code. And thereafter run npm start again to start NodeMon again. Now this is a package which I import here under body-parser. You can name the constant however you want. From body-parser into app.js. Body-parser gives us ready-to-use middlewares, which we can use in Express apps, to parse incoming request bodies. It allows us to get rid of all that code in our first middleware, and instead of writing our own function, here we can write body-parser.json or .url encoded. .json will become important later. This will allow us to automatically parse all incoming requests for JSON data. Here, I will get a regular form data, which the browser generates for me when I click the submit button. And hence here, I will use URL encoded. To that, you need to pass an object to configure it and set extended to false here in this case. Now, this will parse all incoming requests and try to extract any data which is in their body if it's of type URL encoded data, which will be the case for such a submitted form. It will also call next for us, so it will also automatically move on to middlewares after this. Now, in addition, I now want to handle a post request in a specific middleware. And for that, instead of using use, which allows us to register a middleware that runs on all incoming requests, I will use post, which allows me to register a middleware which only triggers on incoming post requests. So where the HTTP verb is post. Then here, I want to have my middleware function with request, response, and next. And in there, I want to return this response. Now I also don't need to return it anymore because there is no code thereafter which I would want to skip. We can now get rid of that if statement. Request body will exist, by the way, because the body parser automatically creates and populates such a field on the request object. However, the username will be available under the name we picked here on the input. So there I picked username, so I have to use username here as well. Now that other middleware here also shouldn't trigger on all requests, but let's say on get requests. So here I can use get instead of use. And now we're filtering for requests which use a get method. If we now save this, everything will restart automatically. And if I now hit enter on my URL again, I get an error. Now I do get this error because get and post actually need at least two arguments. The first argument is not the middleware function itself, but a string which identifies the path, so the thing in the URL after our domain, which should trigger this middleware. So we're not just filtering by HTTP method, but also by path. And here I want to filter for a slash, which means for a request targeting slash, this function will run. So if I now save this and I hit enter again, we see the form. If I enter slash users here, we don't see it. So it is really just slash. You can also add such a filter on app use, but there it's not mandatory. And also it will work as a starting filter. So slash would work for all requests that start with a slash after the domain, which means really all requests. Slash users would handle all requests that start with slash users after the domain, even if it's slash users slash new. Here for get it's different. It has to be exact match and the path is not optional. It has to be provided instead. Same for post. And we can also take this as a chance and, for example, use slash user here as a URL and tweak the form to provide the action attribute to tell the browser where to send the request to so that it sends it to slash user. So the domain slash user. If we now save this again and I hit enter here, we get the form. If I enter menu, you see the URL changed to slash user, and indeed, we see the user being output here. And that's really important. The username here, we didn't have to parse it on our own. Instead, this built-in middleware did it for us. And that's the power of Express. We have this middleware-based approach, which allows us to create our own middlewares, which is very useful to funnel a request through multiple steps and the response as well. But we can also plug in existing third-party library middlewares to get functionality like this body parsing out of the box without having to write the logic on our own, which of course really simplifies things for us and allows us to focus on our core business logic. This is basically it for this Node Express refresher. Now obviously there's more to Node and more to Express. We'll learn about a lot of our features throughout our course project. I don't want to explain everything about Node Express here in this refresher. Instead, we'll also learn more things later. But as I also already mentioned earlier, this course doesn't replace a complete Node Express course. I do have a dedicated course for that, so if you want to learn everything about Node Express, then definitely have a look at that course as well. One final thing which I want to do here is I really want to make sure that we all understand how this code executes and when what executes, because that can be confusing at times. When we start NodeMon with npm start, or we run our file with node app.js, which does the same if we ignore the live reloading functionality, then what happens? It's important to understand that when you execute this file with Node, the entire file is parsed and executed. So this means these imports are parsed and executed. So Node.js goes into these packages, runs their code, and gives us back whatever they export. We'll see the export syntax and how we can use it on our own later, by the way. Thereafter, this constant is created, and then all these use, post, and get methods are called, as well as the listen method. What's not being executed immediately when we execute this file are these middleware functions here. Not because Node has a special exception for them, but because of the way JavaScript works. These functions here are callback functions provided as arguments to post, use, and get. And therefore, JavaScript registers them, stores a reference, a pointer to that function in memory, but only executes them once they are getting called. And we are never calling these functions. Instead, with post, use, and get, we basically let Express.js set up some logic which will execute these functions for us when a request is reaching our server and that request meets our criteria here. So it's a post request with this path or a get request with this path, or in case of this middleware, any request. Only then these functions get executed. It can also be confusing that here it doesn't look like we're actually passing a function. Instead, I am executing a method here. Well, this actually returns a function though. So here, this also registers such a to be executed function. And these functions really only run for incoming requests, not when we start our server and execute app.js with Node. No, these middleware functions are executed for incoming requests on these requests. And that's it with the refresher. I hope the basics are clear. Again, check out further resources like my course or the official docs of Node and Express if you want to learn more. With that, we can move on to the Node Express app for our actual course project and start working on that.